Alright, Chapter 5, Welding Carbon Steels, Low Alloy Steels. 5-1 General. Steel's commonly used with the construction, building, bridge, with the piping specifically covered with the specification of the American Standard Institute, the Army, Iron Steel Institute, the American Society of Mechanical Engineers, Society of Automotive Engineers, American Petroleum, or APL, with these specifications other than refer to the same type of steel, although they did here put differently the restriction for the chemical analysis of the mechanical properties commonly used with the materials, well, the construction for the building of the bridges must meet with the specification of American Society materials, the A36, A203, A242, A440, A4041, A51, 4, A51 7, A54 57 2, A58 8. The piping system has specification American Standard testing materials A53, A4106, A134, A139, A671, A672, A691. American Petroleum Institute 5L, 5LX, 2H with carbon and low alloy steels with confirmed any of the more other specifications, including military, federal, and can be used with where the particular requirements must be met with the welding electrodes for the steel specified in the mill E22. 200 to commonly used with the welding electrodes with the construction most specification American Welding Society A5.1, A5.5, A5.17, A5.18, A5.20, A5.23 welding carbon steels and low alloy steels. The American Welding Society defines weldability as the capacity of the metal with the welded under the fabrication conditions imposed with the specific suitability design structure the performance satisfactory for the intended service of the American Welding Society A.3.0. P55 given the addition with the clear with many of the things with the weldability of the specific steel, with including the joint design welding process with the base metal, with the chemistry, the welded metal chemistry, the mechanical property, the impact of the property for the general steel with the specified with the welding building and the bridge connection with the pipe with the system, and the weldability with the good mechanical properties obtained with the proper attention with the welding procedure for the electrodes. Special selection with the American Welding Society D1.1 contains the selection guide with the technique section of the matches the electrode type of the electrode type of the various American Standard testing and materials, and the American Petroleum Institute steel's manufacturer's recommendations should be followed with the developing the welding procedures, including heat treatment, stress relief with the high strength alloy, confirming the American Society testing of the material A514, A517, and A710. Welding procedure with welding procedure used with governed by the base of the plate with the structure being welded with the position of the weld in flat. Overhead with the horizontal vertical with the chemical composition of the metal with the carbon level with the base with the metal governing the level of the preheat with the U with the rule with the higher the carbon level with the higher the preheat temperature U with the recommended preheat temperature it is given by the American Welding Society D11 and the proper the welding can introduce welding joint defects such as the porosity, slag inclusion, complete fusion, inadequate joint preparation, undercutting the cracking limitation various defects governed with the American Welding Society D11, American Society of Mechanical Engineers boiler pressure valve with the code military MIL R11468 with the acceptance level dependent for the application cracking. Cracking is one of the flaws of the law occurs most often weldments with cracks occur with the temperature for the cooling of the weld base plate within either the two range of the one of the most light with the below with the solidification temperature of the welded metal of the other is forming 4,000 degrees Fahrenheit. The ambient temperature, the high temperature for the cracking cold with the hot tearing occurs because the metal is weak and limited with the plasticity at that temperature. Welds and welded craters heat active with the zone displayed with the type of the cracking, low temperature cracking with the cold cracking, the curve with the root of the pass, the bolt welds and the butt welds in the heated affected zone with the and variously associated with the presence of the hydrogen dissolved impurities. Hot tearing, high temperature cracks in crystalline tears that occur with the near the gauge of the range of the solidification metal for the range attributed to the resins with the low freezing compounds such as the iron sulfide with the solid impurities that have little or no tensile strength of plasticity with the high temperature of these tears are metal with the last of the freeze with the welded deposity for contribution with the signification of the hot tearing while silicon, phosphorus, carbons, and copper, nickel have the less role of the magnesium. On the other hand, with the beneficial with the effect of the hot ductility because the great affinity of the sulfur with the iron does. Magnesium sulfide forms these higher the melting the mating temperature steel and produce the gluber in conclusions rather than intergranular film with the iron sulfide forms, and the ratio of magnesium sulfide steel is 60 or greater. Hot tearing is not likely to occur. Electrodes recommended by the American Welding Society D11 or American Society of Mechanical Engineers power boiler pressure vessel codes are as appropriate will produce the weld deposit minimum hot cracking tendency. Preheating with the controlling of the interpath the temperature. Welding as little with restraint as possible are the other ways of controlling cracking, particularly in severe section thickness greater than 1/2 inch. Cold cracking occurs with the heat affected zone metal or the welded metal that meets with the cause of the mechanical effects of allowing the alloy contact with the hydrogen pick up with the moisture in the electrode flux or on the surface of the welded joint mechanically with a high shrinkage of stress of the introduced with the welded metal by the cooling welding and the restraint action of the base metal stress action act as direction parallel to the perpendicular to the weld. Their magnitude made greater than enough to cause the cracking. In any thickness of steel, the cold cracking may occur with the heat effective zone because of the alloy content that's caused the underbeating of the cracking. The higher the alloy content, the greater the tendency, susceptibility underbeat with the cracking may be estimated with the stainless steel carbon equivalent, which is determined with the formula. Carbon equivalent is equal to percent of the carbon plus 6% of the magnesium over 6 of the plus the carbon chromium and molybdenum and volt V over divided by 10. As the CE increases, or the carbon equivalent increases, so does the susceptibility of the steel of the cold of the cracking. As steel alloy contains the carbon equivalent increases the capability to form hardened microstructures of the shards. Martensite with the wind cold rapidly will also increase the certain areas of the welded joint, particularly with those next to the base of the metal. Heating of the zone effectively may cool rapidly be enough to produce the hardened structure that will become the metallurgic notch for the hard zone, but may be brittle and with the characteristic low notch toughness increase for the heating input with the preheat interpath. The temperature will slow with the cooling rate. However, the high temperature, high strength with lower alloy steel should be preheated carefully so that the steel is heated. Effective zone will not be weak. With the precaution also applies to the use of the interpath. The temperature, air arcing, gouging, and post-welding heating and heat input during the welding. Removal of the defects which may repair the primitive that should be grinded with the air arc gauge. Gouging followed by the grinding to limit the heat input with the effect of the gouging. The steel manufacturer should be consulted with the recommendation of the welding repairs. Few of the steels used in the bridge of the building construction piping system had enough alloy elements to create a problem with the hardening of the in the heat effective zone occasionally. However, the designer might be specifically with the steel that causes the harden quickly enough to require the preheating. The preheating temperature for many of the steels are listed following documentation: structural steels, the American Welding Society D11, piping materials, and American National Standard Institute B311. Various metals, American Society of Mechanical Engineers, Boil Pressure Vessel Code, Section HI, Appendix 3. Other applications of the text welding of abilities edited with the Strout duty. Hydrogen also contributes to the cold cracking. 3 factors for simultaneously hydro-induced cracking. The dissolved hydrogen, tensile strength, the low ductile microstructures such as martensite. Such hydrogen is shielded with the gas flux, and the surface of contamination of hydrogen is carried with the diatomical molecule with the arc of the converted with the monoatomic, the ionized state with the monoatomic hydrogen readily dissolved with the molten welded metal. This exact mechanism by which the hydrogen caused the cold of the cracking has not been fully explained, but many of the investigators believe that the welding metal cools, becomes saturated with the hydrogen sulfide, diffused with a highly stressed area of the heat-infected zone in or atmosphere. One of the heat-effective zones are the authorized for the hydrogen embrittles to the metal with the sum of the low alloy steel, such as the American Society testing materials A514, A2017, will transform martenites under the rapid cooling condition at the same time they entrap some of all the hydrogen present. However, by the hydrogen low vulnerability in the martensitic structure tended to mitigate with the neighboring discontinuities. Along with external forces, hydrogen enabled the flaws with the critical side with regard to the mechanism by which the hydrogen embrittles with the carbon low alloy steels. However, the precaution should be taken against the environmental entrainment jointly designed with the intention of the fitting up to reduce the change of the cold and cracking to control the hydrogen-induced cracking. Post-weld temperatures of 300 to 400 degrees Fahrenheit for the up to 10 hours, depending on the welding thickness, is recommended. Technique should be specified with the caution because of the risk noted with the 3 below. Cleaning the joints to remove the hydrogen containing the materials such as the oil, grease, and using the low hydrogen electrodes is also recommended when it is source for the hydrogen. Reheating cracking. Reheating cracking occurs with the steel containing with the carbide forming alloy elements such as vanadium and molybdenum. The post-weld of the heat, the treatment is used, but those materials often exhibit precipitation alloy carbides, which make the grains of the heat-affected zone stronger than the grain boundaries. And if there's stress in the grain boundary region, must be adjustment. adjusted for the relieve the extensive deformation of the grain boundary regaining, but inducing the cracking, especially in the heated effect of the zone. But the risk of reheating the cracking can be reduced by the using electrodes that do not have the yield strength much higher than that of the base plate, avoiding the high rigid lead joint details with the thick plate, grinding with the metal bullet welds, fleshing and smoothing of the contour fillet welds, especially with the toe of the weld. The American Welding Society D11 section, workmanship stress, relief heat of the treatment of the American Society of Mechanical Engineers, boiler pressure vessel code section 8 proceeds with Walsh welding heat treatment that contains the recommendation practice for the heating welding. Heat treating welds for the stress relief heat treatment of the quench for the temper with the American Society testing material A514 I517 but not usually recommended. It may be required for the maintaining dimension stability during machining. Other defects can be introduced by the welding metal, but the properly welded process technique is not used. For the defects included the prosperity of the slag inclusion of fusion and inadequate joint preparation undercut. Each of these is described in paragraph 4.2. Alright, 5.3, joint design. Welded joints are prepared with either flame cutting, mechanical machining, the grinding, depending on the joint details. Before the welding of the joint surface may be cleared with all foreign materials, such as the paint, dirt, scale, or rust. Suitable solvents or light grinding can be used for the cleaning. The joint surface should not be nicked or gouged since they have interfering with the welding operation. 5.4 methods of welding carbon steel with low alloy steels. Carbon steels with low alloy steels. Carbon and low alloy steels are readily welded with the field with the shield metal arc welding, gas metal arc welding, flux core arc welding, submerged arc welding, and shield metal arc welding. Shield metal arc welding is used often because the equipment is simple and portable. With the gas metal arc welding and the flux core arc welding and submerged arc welding are being used more often in the field because of the weld quality and economic standards. Joined the design, these processes are in the American Welding Society D11 section of the design of the welding connections. American Society of Mechanical Engineers boiler pressure vessel code subsection B with the joint details of the pressure vessel recommendation. Preheat the temperature for the commonly used steels are also given with the codes. These figures are based on the plate thickness, ambient temperature, recommended preheat temperatures of various steels are listed in American Welding Society D11 section technique of Appendix R, the American Society of Mechanical Engineers boiler pressure vessel codes. Art 5.5 shielded metal arc welding. Shielded metal arc welding have been preferred with the method of the welding because of the versatility and simplicity of the equipment, the wide selection of the electrodes. All of these characteristics are important with the field weld application. American Welding Society, the A51 and A55 specify the mild steel, low alloy steel. American shielded metal arc welding. Electrode classification system. American Welding Society has developed a classification with describes some of the characteristics of the steel welding electrode with the shield metal arc welding classification code are made up of the E and 4 or 5 number. The E indicates the mentioned metal, but it is included. Metal is electrode, but the 2 digits of XX give the minimum tensile strength of the weld deposit in 1,000 pounds per square inch. This is an electrode with the E70,000. E70 is ZY classification would have the minimum tensile strength of the 700 psi tensile strength designating starting with the 60 to increase by 10 to 120. Number of representation of Y can either be 1 or 2 designating the proper welding position with electrode. A1 means the electrode can be used with all positions of flat, horizontal, vertical, and overhead. With the 2 indicates that it can be used in flat, horizontal fillet. Well, the last term of the classification Z can be any of the number of the 0 through 8. The numbers identified with the American Welding Society indicate the major coding of the constitute for the welding current types. Chemical requirements. American Welding Society divides the shield metal arc welding shield metal electrodes into the 2 groups of mild steel. American Welding Society A51 and low alloy steels. American Welding Society A5A. The E60XX and E70XX electrodes are mild steel specification. The chemical reaction. The E70XX electrodes are listed with the American Welding Society A5.1 alloy with a wide variation combination of the deposit with the welded metal. They are not specified with the chemical requirements for E60XX electrodes. The low alloy specification containing electrode classification for E70XX and E120XX. These codes they suffix introducing chemical requirements of the class of the electrodes. For example, E7010A1 and the E8018C1. Composition low alloy E70XX electrodes are controlled much more closely than low mild steel. E70XX electrodes, low alloy electrodes are low hydrogen classification. EXX 15, EXX 16, EXX 18. Require special handling to help the coating from the picking up the water manufacturer recommendation above the state or its banking and back in the found with the 4 of these electrodes. The American Welding Society A55 provides a specific listed in the chemical requirements. Welding metal mechanical property requirements of American Welding Society requires the deposit of welded metal to have the minimum tensile impact strength. The detailed requirements for the mild steel electrodes are listed in the American Welding Society A51 for the low alloy steel electrodes by the American Welding Society A55. Recommended with the filler metal for the common use for the steel with the common use of the American Society testing material for the American Petroleum Institute. Steel's machine filler metal requirements are listed with the table. The machine filler metal requirements of American Welding Society D11. Load documents list for the steel minimum the preheat and the interpass for the temperature for the different plate thicknesses. Welding process for steel is not listed with the manufacturer recommendation. Should be filed with the American Welding Society A51 contained with the intent of the use of the electrodes as appendix for the chemical composition. Also should be considered with the low electrode as specified. 5.6 General gas metal arc welding. Gas metal arc welding being used more often with the shop at the field. The application becomes the more commonly the shield metal arc welding. The gas metal arc welding is much less downtime with electrode changes, much less loss due to the stub and the end of the spatter, with much less the interpass cleaning required. The gas metal arc welding is slightly less versatile because of the welding gun and bulkier than the electrode holder of the shield metal arc welding. However, the gas metal arc welding can be used with all position with either short circuiting the transfer of the pulse voltage power supply, but this equipment is more complex with the more expensive than the shield metal arc welding. Requires more skill within the part of the operated electrode classification. System classification code for the gas metal arc welding electrode wire is considered for the E and the 4-figure for the configuration E, X, X, Y, Z. As with the shield metal arc welding, the E stands for electrode, the XX gives the deposit tensile strength of 10,000 pound increment of the tensile strength designation from the 70 to 110. The next digit of the Y can either be S or U, and S is a solid bare wire. U means the solid wire has an emissive coating that allows the DC straight polarity. The final digit is Z and can be any number through 1 through 6 or the letter G. The number indicates the chemical analysis, particular carbon silicon. The G classification has no chemical requirements. The letter B at the end of the code, such as the E70S1B or indicates a low alloy steel electrode only on the E70X. E70X-U1 and electrodes are specified in American Welding Society AS18. Chemical requirements. Chemical requirements for the gas metal arc welding electrodes are present with the American Welding Society AS18. In the E70SG and ES7SGB electrodes have no chemical requirements except for the no addition of the nickel, chromium, molybdenum, vanadium allowed. Chemical requirements for the high strength low alloy electrodes for the mil E, the 18193, mil E 198022, mil E 237654-1, mil E 237562. All chemical analysis are based on the as the manufacturer electrode wire. The welding metal mechanical properties, all welded material tensile strength properties of the E70 electrodes are presented with the American Welding Society in A518. The shield gas are two shield gas for the use with the gas metal arc welding carbon dioxide argon plus 1 for 5% with the oxygen. In addition, carbon dioxide is used with the short circuiting transfer of the flat position welding arc oxygen. Shield gas is used to pole side voltage out position welding with a straight transfer of welding. The gas metal arc welding electrodes recommended with the shield gas for listed in the American Welding Society A518. The recommended filler metal for the commonly used for the steels of the table, the matching filler metal requirements of the American Welding Society D11 listed commonly used for the AS American Society testing materials, American Petroleum Institute specification number to give the matching filler metal requirements classification. In addition, with the American Welding Society D11 list for the steels, the minimum preheat and interpass temperature for the different plate thickness welding processes. If the steels are other than those listed for the use of the manufacturer recommendation for the welding metals preheat, the temperature should be followed. This intended use for the electrode types include with the Appendix A, American Welding Society A518. 5.7 Flux core arc welding. Flux core arc welding is equipment similar to that of the gas metal arc welding. The advantage becomes the higher the deposition flux ingredient to process primarily the flat horizontal welds, but can be used in other positions properly. Electrode diameter and welding currents for the selective mill steel. Flux core flux core arc welding electrodes specified with the American Welding Society A520. Low alloy flux core arc welding electrodes available. The manufacturer recommendation for the use of the B fouled electrodes classification system. Florida flux core arc welding electrodes are classified similar with the gas metal arc welding electrodes. In case for the EXXXTY, the EXX designates the same as the shield metal arc welding. Gas metal arc welding electrodes can either be E60TY or E70TY. Letter T includes the continuous tubular electrode with a powder flux filling with a tube. The Y, which in this case are many other numbers from 1 to 8, the letter G or the letter G indicate the deposited welded metal chemistry and the shield gas used. Chemical requirements: deposited weld metal chemical analysis, the mild steel, the flex core, arc welding electrodes, and American Welding Society A520. There are no chemical requirements for the E72E, E70T2, E72T3, and E70TG electrodes. Welding mechanical property. All welding metal tensile impact requirements for the mild steel and flux core arc welding electrodes are presented with the American Welding Society A520. Shield gas. The flux core arc welding electrodes are carbon dioxide with a shield gas containing the flux gas producing the compound to protect the arc from the atmospheric competition and the contamination. E60, T70, E60TA, E60T4, and E60T6 electrodes need no external shield gas. E70T1 and E70T2 electrodes need shielding from carbon dioxide. E70T5 electrode can be used with or without carbon dioxide as separate shield gas, with a shield gassing with the ESC70TG electrode is not specified. Recommended the filler metals commonly used with the seal, with the commonly used seals listed in the American Society Testing Materials, American Petroleum Institute specification number, the table, the branching of the filler metal requirements over the American Welding Society D11, and the specification also gives the matching of the filler metal requirements electrode classification that meets with the requirements of electrode E70T2 and E70T3, but they're not recommended with the American Welding Society code. The table, the minimum preheat interpad for the temperature, American Welding Society D1 categorized commonly used for the steel plate thickness welding process with the ways they are associated with the preheat interpad for temperatures. If the steel has other listed but not use the manufacturer recommendation for the welded preheat temperatures, and should be filed with the American Welding Society A520 with the flux core arc welding electrodes containing the appendix that listed intended for the use of electrodes. Alright, submerged arc welding. Submerged arc welding is limited to flat and horizontal fillet welding because of the granulated fluxing used for the particularly arc and the molten welding metal. The submerged arc welding electrode flux of the middle mild steel is specified with the American Welding Society A517, low alloy weld metal specified with the American Welding Society A523. Material classification system: submerged arc welding flux core. The two parts of the first refers to the flux and second to the electrode. The classification had the following with the flux FXX, EXXX. F indicates the material is flux. The first number indicates the minimum deposit weld and tensile strength of 10,000 psi increments. This digit can be either from 6 to 12. Last number of each of the parts indicate the impact of the deposit weld material. Example: the flux designates F61, F86, F128. The next part of this classification begins with the E, and the designates the electrode with the mild steel with a 3 or 5 digit code used for the first digit, either an L or an M or an H, indicate the relative of the magnesium content with the electrode, Y with the next one of the two digits for the nominal with the carbon content with the electrode, Y with the code may be followed with a K, with which shows that the wire may be made from silicone killed with the heat with the steel. Example: the mild steel code will be EL8K and EM12. The alloy electrodes have similar coding with the system with the E, again indicating electrode, the next 2 or 3 digits indicating the manufactured wire chemistry, and the final part of the indicates the deposited welded metal chemistry of the parts. The code system applied for low alloy classification only with the suffix N indicates the material for the nuclear grade. Example of the SAW classification: the F70, the EL12A1 combination for the carbon molybdenum low alloy steel, F86 EB2 B2 combination for the chromium molybdenum low alloy steel, 561 EM12K combination of a mild steel. Alright, the chemical requirements for the electrochemistry and composition requirements are represented with the American Welding Society A517 metal mild steel, American Welding Society 523 low alloy steel deposit welded metal with the chemical requirements presented with the American Welding Society 523 low alloy steel. Only chemical composition requirement for the flux, the combination flux and low alloy steel electrode produced for the specified deposit weld metal chemistry. Welded metal mechanical property. All the metal tensile impact requirements for the mild and low alloy steel welds are represented with the American Welding Society 517 and 523, respectively. EXXX after the flux designation means the flux will produce the strength when used for the combination with any electrode. Recommended filler metal for commonly used for the shield with the table limit matching filler metal with requirements in the American Welding Society D1.1 list for the American Society Test Materials. American Petroleum Institute classification commonly used steel for the matching filler metal requirements of electrical classification meet the requirements of the table. The minimum preheat to interpass. American Welding Society D11 list for the steel of the minimum preheat to interpass the temperature for the range of the height of the thickness of the various welding processes in the steel other than those listed that are usually manufacturer recommendation for the welding metals. Preheat temperature should be filed with the appendix American Welding Society A517, A524, list of usages and choice of flux for the submerged arc welding process. Chapter 6, Welding Aluminum Alloys.